7.2, verifying solutions. So it says derivatives can be used to verify that a function is a solution to a given differential equation. We also covered some of this in 6.8 where we found particular solutions. So it says, let's remind ourselves how we did that. So this first question right here is just a repeat of 6.8 notes. So it says, if dy dx is equal to e to the 2x minus 2x squared, find the particular solution of y if y of 0 is equal to 4. So in order to solve this, we first need to get this in terms of y, which means we need to integrate both sides. So I take the integral of dy dx is equal to the integral of e to the 2x minus 2x squared dx. I'm left with y is equal to the integral of e to the 2x dx minus 2 integral of x squared dx. I just separated it into two integrals. Okay, from here, let's use u substitution for that very first integral. So let u equal to 2x. So du dx is equal to 2, which means dx is equal to du over 2. So I'm going to end up taking out a 1/2. So I have y is equal to 1/2 e to the 2x, okay, minus 2x cubed over 3 plus c. Okay, so this is my general equation. But since it gave me the point 0, 4, I can plug that in and solve for c. So I have 4 is equal to 1/2 e to the 2 times 0 minus 2/3 times 0 cubed plus c. Okay, this is going to go away, and then e to the 0 is just 1, so technically that goes away too. So then I have 4 is equal to 1/2 plus c, which means c is equal to 3.5. So my particular solution is y is equal to 1/2 e to the 2x minus 2/3 x cubed plus 3.5. Okay, so again, that's when we learned about particular solutions where we could solve for c. However, we may not see our problem in this unit written like that. Instead, we might see something that says a curve has a slope of e to the 2x minus 2x squared. Well, slope is the same as dy dx. At each point xy on the curve, what is the equation for this curve if it passes through the point 0, 4? Again, same as it giving us our conditional of y of 0 equals 4. So you would answer this the same way as number 1. Okay. Well, let's say we have something a little bit more complicated like number 2. Number 2, it gives us the second derivative. So if we need to find the particular solution for y, that means we need to end up taking the integral 2 times. Okay. So I have the integral of d squared y over dx squared is equal to the integral of 1 over x squared plus 1 minus 2x squared dx. So this gives me dy dx is equal to the integral of 1 over x squared dx plus integral of 1 minus 2x squared dx. I'm going to use u substitution on that second integral. So I say let u equal 1 minus 2x. So du dx is equal to -2, which means dx is equal to du divided by -2. So I'm going to end up taking out a -1/2. Okay. And then I can also write this as x to the -2. So I have dy dx is equal to x to the -1 divided by -1 plus, well, minus 1/2 because I got to take that out. And then I have 1 minus 2x to the 3rd over 3 plus c. So really, I have dy dx is equal to -1 over x minus 1/6 times 1 minus 2x cubed plus c. Okay, so I need to actually find what that C value is, and I can use one of my conditionals up here that states that y prime of 1 is equal to 7, 6, which means dy dx is equal to 7, 6 when x is 1. So I have 7, 6 is equal to negative 1 over 1 minus 1, 6 times 1 minus 2 times 1 cubed plus c. Do algebra, and we get that c is equal to 2. Okay, which means I have that dy dx is equal to negative 1 over x minus 1, 6 times 1 minus 2x cubed plus 2. And then I integrate that one more time because I want it in terms of y. So I have the integral of dy dx is equal to, and I'm just going to go ahead and separate the integrals right off the bat. So negative integral of 1 over x dx minus 1, 6 integral of 1 minus 2x cubed plus the integral of 2 dx. So then simplifying this, I have y is equal to negative natural log absolute value of x minus 1, 6, and then remember when I used u substitution before, a negative 1/2 came out. So times negative 1/2 times 1 minus 2x to the 4 over 4 plus 2x plus c. So simplifying that, that is y is equal to negative natural log absolute value of x plus 1 over 48 times 1 minus 2x to the 4th plus 2x plus c. Well, now I can use the conditional y of 1 is equal to 0 and plug it in to find c. So I have 0 is equal to negative natural log of 1 plus 1 over 48 times 1 minus 2 times 1 to the 4th plus 2 times 1 plus c. Do some algebra. And we get c is equal to negative 97 over 48. And so we get our particular solution to be y is equal to negative natural log absolute value of x plus 1 over 48 times 1 minus 2x to the 4th plus 2x minus 97 over 48. And that would be my answer. Okay. The next part says recall. So recall what it means to take the derivative of sine. Well, the derivative of sine is cosine. And the integration of sine is negative cosine plus c. The derivative of cosine is negative sine. And the integral of cosine is sine plus c. So using that information, we're going to answer number 4. Number 4 says, for what value of k, if any, will y equal to k times e to the negative 4x power minus 2 times sine of 5x be a solution to the differential equation y double prime plus 25y is equal to negative 82e to the negative 4x? Well, in order to see if this would be a solution, or what k value would make it a solution, we have to first take our equation for y. So y is equal to k times e to the negative 4x minus 2 times sine of 5x and take the derivative. Well, the derivative, okay, using the power rule and the chain rule, we get negative 4 times k e to the negative 4x minus 10 cosine of 5x, and then take the derivative again, and we get 16k e to the negative 4x plus 50 sine of 5x, and then I'm going to plug in this y prime for this y prime, and then plug in this y for this y. So I have 16 times k e to the negative 4x plus 50 sine of 5x plus 25 times k times e to the negative 4x minus 2 sine of 5x, okay, is equal to negative 82e to the negative 4x. So I'm then going to distribute that 25, and I get 16k e to the negative 4x plus 50 sine of 5x plus 25k e to the negative 4x minus 50 sine of 5x is equal to negative 82e to the negative 4x. Well, that is going to cancel out the 50 sine of 5x, and then I can combine like terms, and I get 41k e to the negative 4x is equal to negative 82e to the negative 4x. Well, remember, I'm trying to get k by itself, so I'm going to divide both sides by 41e to the negative 4x. E to the negative 4x cancels out, and I'm left with negative 82 over 41, which is equal to negative 2. So that means the k value that will make this a solution to the differential equation is when k is equal to negative 2.